Welcome to the deep dive. So, there's been this really lively debate kind of buzzing through the AI engineering community lately. You see it a lot on social media.
Oh, yeah.
It feels like everyone's had to sort of pick a side, agents versus workflows.
Right, that's exactly it. And, well, that's the challenge people have pointed out. Our mission today, though, isn't really about picking one.
Okay.
Instead, we're going to try and distill some insights from different places to show why the answer probably isn't either.
More like, why not both?
Exactly. How these two powerful ideas can actually work together, complement each other when you're building real AI applications, robust ones.
Okay, so what really kicked this off? I know we've got a couple of key sources that sort of shaped the whole conversation.
We do. First up, there was that blog post from Anthropic back in December, Building Effective Agents.
Right, I remember that one. Got a lot of positive buzz, as you'd expect.
It did. But then fast forward to April, and OpenAI releases this paper that, well, it really lit a fire under the debate.
Yes. That one definitely generated a lot of talk. And some
Sure.
controversy, too, right?
Yeah.
About it being potentially, like, anti-workflow.
Precisely. And that perception, whether intended or not, is where a lot of the online heat we're going to unpack really started.
Okay, let's unpack that, because the online discussion, it did get pretty intense. That OpenAI paper, and yeah, that perceived anti-workflow angle, it seemed to genuinely worry some folks. The feeling was maybe a big model provider was simplifying things too much, or even, as some put it, kind of muddying the water.
Yeah, and that led to a couple of, let's say, strong observations bubbling up in the community. The first one was this sort of don't dictate the path feeling, basically saying, look, large influential companies maybe shouldn't be telling everyone this is the only right way to build things.
You know, that resistance, it really reminds me of debates from, wow, maybe a decade ago in web development.
Oh, sure.
Remember when, like, certain big tech companies pushed very specific frameworks or technologies? Sometimes they felt, well, overly complex or maybe not the easiest thing for everyone else to just pick up and use, almost like an alternative to maybe more common approaches.
That's a great parallel. And the hope here, I think, for AI is that we can have a higher quality of discussion.
Right.
When companies that are that big, that influential say something, it carries a lot of weight.
Right.
So clarity, impartiality, practicality, those things are really important. If that's missing, it can actually slow things down for everyone.
Totally agree. And building on that idea of influence, there was a second big point that came out of this debate. It tackled something different, but just as important, really. API design.
Yes.
This was the idea that maybe GraphNode and Edge terminal APIs within frameworks are, well, potentially harmful.
That sounds pretty strong, doesn't it?
Yeah.
But let's maybe ground it with an analogy.
Yeah.
Again, going back to web dev. Think about Gatsby, the React framework. The co-founder talked about this. They use GraphQL as the default for data fetching.
Right. I remember GraphQL being a big part of it.
Yeah, and GraphQL is great tech, but making users basically learn graph theory just to pull some data, that was a real hurdle for a lot of developers. It just added, extra thinking time, extra complexity.
Yeah, it was powerful, but definitely had a learning curve. And the connection here is you and your team shouldn't need a PhD in graph theory just to build production AI apps today, right?
Exactly. That level of abstraction, it often kills readability.
Yeah.
And readability is just so critical when you're building software with other people on a team.
Absolutely.
So you contrast that with what people will often call fluent syntax patterns.
Yeah.
You see them in frameworks where the code reads more naturally, top to bottom, like a chain of actions.
Much easier to follow the logic.
Yeah, you can just read it and get what's happening, how the pieces connect. That's huge for collaboration, for maintenance down the line.
Okay, so we've touched on the debate, some of the community reactions. Let's get to the core here, demystifying agents and workflows. Because one issue right now is we don't really have a standard dictionary for all these agentic patterns and agentic workflow patterns.
That's very true. The language is still evolving, for sure. But if we try to break it down simply, often think of agents like a turn-based game.
Okay, interesting.
You do something, the agent does something, maybe calls a tool, then you respond, it responds.
Yeah.
It's this back and forth loop. And what emerges from that, like from all those messages building up, is stuff like conversation history, memory, different threads maybe.
That makes sense. Like a conversation with state.
Yeah.
And workflows, how do you picture those?
For workflows, I kind of like the analogy of a rules engine for your tech tree in a strategy game.
Oh, like civilization?
Exactly.
Yeah.
Like you need to research bronze working before you can get to iron working.
Yeah.
Or, mysticism before gunpowder. Workflows set up those dependencies. A, then B, then C.
Hmm.
Often like data pipelines, right? Step A, B, C, D, E, usually in order.
Got it. A sequence with rules.
Right. And workflows, they also have their own cool emergent properties. You get branching, running things in parallel, conditions, loops. You can pause them, resume them, even replay them.
So workflows aren't new. Obviously, they've been in software forever. But why are they suddenly so huge in AI engineering now?
That's a great question. I think the core reason boils down to non-determinism.
The fact that AI models don't always give the same output for the same input?
Exactly. In regular software, figuring out what went wrong is
Yeah.
important. But in AI, where things can vary, it's like 10 times more important to be able to trace back what happened, why it did that specific thing this time.
Makes sense.
Workflows give you that structure, that transparency, that traceability. It's just vital for building AI systems you can actually rely on.
So when you're designing these systems, it sounds like there's this fundamental trade-off. You've got like raw power on one side, flexibility, doing lots of things, and control on the other, reliability, predictability.
That's a perfect way to put it. It is always a trade-off.
Mm.
But what's really cool is you don't have to pick just one. You can start with the power, maybe let an agent be very flexible, and then add specific controls to the parts that seem to go off the rails reliability-wise.
So target the control where you need it most.
Precisely. This is a key design principle, really. Use the power where adaptability matters and layer in control where you absolutely need things to be dependable.
Yeah, that makes a lot of sense. Like, instead of having one massive LLM call, try to pull 12 different symptoms out of some complicated PDF.
Right, which might miss some or hallucinate others.
You could break it into 12 smaller, focused LLM calls, each looking for just one symptom. Probably much more reliable, right?
Yeah.
And easier to debug if one fails.
Absolutely. That kind of decomposition often boosts reliability dramatically. It's actually a good practice we find. Try explaining your AI system design to someone else. Draw it out.
Whiteboard it.
Yeah. You'd be surprised how often just doing that suddenly makes you see, oh, wait, there's a simpler, better way to use these pieces I already have.
Okay, so breaking things down helps. But the real excitement, it seems, is when you actually combine agents in workflows.
Yes, that's where the magic really happens, as they say. The core idea, it's actually pretty simple. Agents have tools. Workflows have steps.
Okay.
So an agent can be a step in a workflow, and a workflow can be a tool for an agent. They compose. You can plug them together in these really powerful ways.
Gotcha. So let's talk patterns then. What does that look like in practice?
Well, one common one is the agent-supervisor model. You have one agent, maybe an orchestrator, that calls other specialized agents as its tools.
Like one agent finds research papers, another summarizes them, and the supervisor puts it all together.
Exactly like that.
Huh.
And what's neat is these setups can often be quite straightforward conceptually. You could probably sketch it out on a single slide and people would get it.
Okay, that's one pattern. What else?
Another is using workflows as tools. Imagine a really complex workflow. Maybe it plans a trip by first checking possible locations, then getting weather forecasts, then booking flights and hotels based on that.
That sounds like multiple steps.
Right, you could package that whole multi-step workflow up and give it to an agent as a single tool. The agent can then decide when and how to use that complex plan-a-trip capability.
Interesting. So the workflow handles the structured part. The agent decides when to trigger it.
Precisely. And workflows can also manage handoffs between agents, which ties into another important idea, dynamic tool injection.
Okay, what's that?
Well, agents sometimes struggle if you just give them like 20 different tools all at once. They can get confused.
Too many options.
Yeah. So dynamic tool injection is about smartly giving the agent only the specific tools it needs for the immediate task or subtask it's working on. Workflows can help manage which tools get injected when.
Keeping the agent focused. Makes sense.
And of course, just like regular code, you can have nested workflows. A whole workflow can just be one step inside a larger workflow.
Okay, so lots of ways to combine them.
Absolutely. And keeping this back, the real advantage, the real alpha, as some might say, comes from using these different patterns together smartly. Because reality is messy, right?
Definitely.
Reality has a surprising amount of detail, and agentic workflows, once you try to build them for real production use cases, they end up needing that detail too.
So this brings us to a really interesting point about AI engineering itself. You hear people say it's more of a community of practice right now than a community of theory. What does that actually mean for people building stuff?
It means, basically, if you build an agent, and hey, maybe you gave it 20 tools, and the theory says that's too many, but it works.
Then do it.
Then do it. Don't wait for a paper to tell you it's okay if you've found something that solves your problem in practice.
Right. So the implication there is kind of provocative, isn't it? If your practical result bucks the current theory.
Then maybe the theory needs an update, not necessarily your working solution. This field is just so young. The practice, what people are actually building and getting to work, is genuinely moving faster than our theoretical understanding can keep up sometimes. It's a pretty exciting time to be involved.
Okay, so wrapping up this deep dive then, the big takeaway isn't about choosing sides. It's not agents or workflows.
Yo.
It's about understanding how to cleverly combine them, compose them, using both strategically to tackle those messy real-world problems, finding that right blend of power and control for whatever you're building.
Exactly. So maybe a final thought to leave everyone with. Given that this is a field where practice is leading theory, what completely new ways of doing things, what new best practices might you uncover?
Just by experimenting.
Yeah, just by playing with these combinations, trying to get your own projects working. What undiscovered patterns are out there waiting for someone to stumble upon them simply by building?